In this video, we're going to take a look at the inter and intramolecular forces that exist between different atoms, molecules, and different species altogether. So our goal is to be able to determine the type of intermolecular bonds found in different molecules, like hydrogen bonds, London dispersion forces, dipole-dipole forces, and also ion dipole forces. First of all, we need to understand what an atomic force is. An atomic force is an invisible interaction, and that can mean an attraction or repulsion, so two things coming together or being pushed away from each other, because of these subatomic particles in the atom or in the compound. So there's two main types of atomic forces. There's the intramolecular, that means within, and it's sometimes called a bonding force, and then intermolecular forces, which are called non-bonding forces. So let's take a look at that here. Here we have the molecule HF. The H and the F are held together by a bond here, a covalent bond. That covalent bond is an example of an intramolecular force. It's a bond found within the HF molecule, inside the HF molecule. But now here we have two separate HF molecules. And the two separate ones are attracted to each other by this little weak force here. And that weak force there is called an intermolecular force. So it's not holding the atoms within the same molecule, just holding separate molecules together. So inter means between different or separate molecules. Intra means within the same molecule. So you might hear, international, between different nations, or you might have heard, so international would be between different nations, different countries. So this would be different between different molecules. Whereas intra, for example, intramural sports. So sports within the same school, for example. So within the same molecule. So let's go ahead and start off with intramolecular forces first, also called the bonding forces. The bonding forces are the ones that hold the atoms together within a molecule or substance. So for example, here, the atoms of O and H's within the water molecule are held together by some intramolecular forces, some covalent bonds. So covalent bonds are examples of intramolecular forces happening within the molecule. The main intramolecular forces that exist are the ionic bonds found in ionic compounds, the covalent bonds found in molecular compounds, and also in grade 12 you learn about something called the metallic bond, which is basically a force that helps to hold metal atoms together and gives them their properties like being able to conduct electricity. So really our focus will be on the ionic and covalent, and within the covalent, of course, that includes polar and non-covalent bonds. So those are both considered intramolecular. The intramolecular forces or bonds, they help to determine the chemical properties of a substance. So not things like boiling or melting, but actual chemical properties, because you need to break those bonds to do a chemical change. So if I want to decompose water to make hydrogen gas and oxygen gas, I would have to break these bonds here. And so that's why these intramolecular forces, they are what determine the chemical properties of a variety of substances. And one thing to point out as well, and just take a look at the energy here. So the energy that you see there is essentially the energy required to, let's say, break these type of bonds. And you'll notice that there's a range. So you can't really say like ionic is always stronger than covalent, but what I want you to notice is that the range is on the higher end for the ionic bonds. So in general, you'll see that ionic bonds are a little bit stronger than covalent bonds. But again, it depends on the type of compound you're dealing with. But you can take a look at that range to make sure that you understand that there is a range of differences, of different strengths, depending on what type of compound you have. Ionic being on the higher end of that range, covalent being somewhere in the middle between ionic and metallic. Now, intermolecular forces, they are, again, non-bonding. They're between the atoms of separate molecules. So here we have three separate water molecules, and within each you have the intramolecular forces, like the covalent bonds are holding them together. But then between this water molecule and this one, let's just focus on those two, you have a weak force here of attraction between the hydrogen and the oxygen. The hydrogen has a partial positive charge because water is polar, and the oxygen has a partial negative charge, again, because water is polar, and the oxygen is more electronegative, so it holds the electrons a little bit closer to itself. But the point is that there's an attraction between the partial positive hydrogen of this water molecule and the partial positive oxygen of this water molecule. And this is happening between two separate molecules, so this is an intermolecular force. And we'll learn later on, as this is actually called a hydrogen bond, but that's a specific example. So we usually represent it by a dotted line. And the reason we represent it by a dotted or broken line as opposed to a solid line is because these intermolecular forces are weaker than the intramolecular forces. So let's take a look at these equations over here. The first one on top here represents a physical process. It's a physical change. We have water going from liquid to gas, so evaporation. That's physical. To evaporate, you need to actually break the hydrogen bonds. So the intermolecular forces, they determine the physical properties, like, for example, boiling point, melting point, and solubility. So if we want to evaporate, we need to break the hydrogen bonds, okay? But here, the second equation shows you a chemical change where you actually break water apart into H2 and O2. So you're coming to break the covalent intramolecular bonds here. And so what you'll notice is to actually break the intramolecular bonds, it takes more energy to break the bonds within, takes more energy than to break, the intermolecular, like these ones here. So that said, the intramolecular bonds are stronger than the intermolecular bonds. Intermolecular bonds are pretty weak. Their strength in numbers, so the more there are, the stronger they are, but they're still very weak compared to the intramolecular. And so once again, it's important to understand that the intermolecular will determine the physical properties like boiling point, melting point, and solubility. They are weaker than the intramolecular forces, as I mentioned, and because of that, we represent them with broken lines as opposed to solid lines. There's several different types of intermolecular forces that exist. There's collectively, there's some very weak ones called van der Waals forces, so van der Waals forces. So you can see there's dipole-dipole, hydrogen bonding, and London dispersion forces. Those are the three weaker ones, and we'll discuss those. And then there's also ion dipole forces. There's a few other ones you might see in grade 12, but for now, these are the main ones that we need to know. And so what we're going to do is we're going to go through our notes and through these slides to take a look at some examples of each one. Just before we do that, we'll fill in some blanks on our handout, but let's take a look over here. So just to summarize, we saw that here we have a water molecule, and the force holding the atoms together within is called intramolecular, and it happens to be a polar covalent bond here. And if you really want to break that, you'd have to put some electricity through it and get to a very high temperature, about 2,500 degrees Celsius. And then you have these forces between separate water molecules called intermolecular forces. This specific example is a hydrogen bond, but it's an intermolecular force, and you'll notice that it boils at 100 degrees Celsius. So much less energy required to break that intermolecular force compared to that intramolecular force. So again, the intra determines chemical properties, the inter determines physical properties. So before we go into this detail here, let's go ahead and fill in some blanks on our note here. So we saw that there are atomic forces, and the atomic forces can be intramolecular or intermolecular. Really pay attention to that key word of intra, meaning within, and inter, meaning between different. So intramolecular forces are called bonding forces, and they're forces that hold the atoms together within a molecule, Whereas intermolecular forces are called non-bonding forces, and they're forces between the atoms of separate molecules or ions. The intramolecular force, remember, that determines the chemical properties, and the intermolecular forces determine the physical properties, like boiling point, melting point, and solubility. Those are the main physical properties we'll focus on. Remember that to do a chemical change, you need to break the intramolecular forces. And generally, intramolecular forces are going to be stronger than the intermolecular forces. The intermolecular forces are weaker than intramolecular forces. And that was highlighted to us in this equation over here. This is a physical process over here, step A, and that required us to use this much energy to break the intermolecular forces. This here is a chemical process, reaction B, equation B there, and that required a lot more energy to break the bonds in water. So this essentially would be reaction B would essentially be breaking these bonds here to get H2 plus O2. It's not really balanced, but that's the idea. And a reaction A would be you have H2O molecules, and this is very rapid here, but H2O molecules. Here's an intermolecular force, like that. Attraction between the O there, and the H there, because they're partial positive and partial negative. And really, reaction A would be just breaking that there, which is a lot weaker, doesn't require as much energy. So here we can see an example again of intramolecular forces. So this is a covalent bond. The various types of intramolecular forces are metallic, that you'll see in grade 12, ionic bonds in ionic compounds, and then polar and non-polar covalent bonds in molecular compounds. And then you can see the relative strengths in these table, with ionic generally being a bit stronger than the covalent, and then metallic being weaker than those. But we're going to focus primarily on these two here when it comes to intramolecular forces. For intermolecular forces, remember, they are weaker, and notice that we don't represent them with solid lines like we do with the intramolecular. We represent them with those broken lines, not the solid lines. And the various types are the dipole-dipole, hydrogen bonding, and London dispersion forces that I sometimes call LDF, and they collectively can be called van der Waals forces. And then another type is also ion dipole. These are the main types that we're going to be discussing in grade 11. Over here, you can see a summary of the different types that exist. So the ion dipole, H-bond, dipole-dipole, and dispersion. You can see the energies required to break them, which gives you a sense of their strength overall. And they're actually arranged from the strongest to weakest that way. So you can come back to that table after we're done going over this lesson to see that you understand all the concepts there, and you have examples given to you as well. And then over here is just our little summary image. So we have an example of an intramolecular force within the same molecule. And then here we have two separate molecules, and then there's an intermolecular force between different molecules, molecules A and molecules B, I should say separate molecules. And so in the next video, we're going to go and take a look at all the forces and do some examples together.